In part C, we want to latch on to the words minimum and maximum to remember what that means in the context of function analysis, stuff that we already know. You'll again notice me highlighting them in that green color, and that's to continue to establish the connection back to part A, where we saw something very important about the relationship between big F and little f. Namely, that if I'm finding minimum and maximum values, I need to understand big F prime, the derivative of big F, but because I don't know any information about big F prime, I have to use it as a springboard to little f. And that connection is what's really going to make this so crucial. The minimum and maximum values are where big F prime is going to be equal to 0. That's generally what we know about minimum and maximum. Minimum and maximum both occur where big F prime would have to be 0, or possibly at an endpoint. Now, if you're not sure what that statement means, I'll just remind you what exactly an absolute minimum or maximum is. An absolute minimum maximum is a critical point or an endpoint. And I'll just flesh this out just in case you need some actual notes. Because the idea with a minimum or a maximum is that it can only occur in a couple of different places. A minimum or a maximum can only occur at a critical point, and a critical point occurs when big F prime is equal to 0, or undefined, although we don't necessarily look at those too much. I'll make that little note here where big F prime, is 0. Refine my writing here, where big F prime is equal to 0, or undefined, or at an endpoint. So I just want to make sure that we kind of give ourselves some parameters, some reminders of vocabulary, so that when we start to look for this information, we know what we're looking for. Minimum and maximum values can only occur in a few different places. So that's why I'm so interested in just a few situations. Where do I have critical points? Where do I have endpoints? Those are the only two places where I could possibly find a min or a max. So those are the only places on big F prime that I need to actually worry about. Remember, big F prime had lots of information. We found tons of information in letter B about big F prime. We really used little f to do it, so we kind of cheated there. But we found lots of information about big F prime. We found all of its zeros. We found all of its pluses. We found all of its minuses. That's a lot of info. And for min and max, we don't need all of that. So that's why I'm taking the time to clarify my vocabulary here. For min and max, I really only need to test any critical points, so any zeros. I didn't have any undefineds on this line chart, so that's why I don't have to worry about that. I only have to look at wherever I had zeros and my endpoints. Now, the absolute min and absolute max can be predictable if you think about the behavior that the line chart is suggesting, but ultimately we know what this boils down to is that we have to test all of these possible points. So I'm going to write down first the values of x that seem to be important according to my line chart. According to my line chart, I had zeros at x coordinate 4, or sorry, negative 4, my bad, negative 2.5, at 0, at 4, and at 6. Now, in theory, any of those is eligible to be a maximum or a minimum. Realistically, what we're going to have to do is test all of these to figure out which one truly has the biggest value of big F and the smallest value of big F. So in order to figure out if something is a min or a max, we actually have to do big F of each one in order to figure out this information. The biggest of these answers is going to be our absolute maximum, and the smallest of these answers will be our absolute minimum. Now, this sometimes is where people use a bit of common sense, because they start to go, oh crap, big F of all these things, dang, that's going to take a while, because remember, big F is not the graph. Big F is this highlighted function from way long ago that we know takes an area to do. Big F of negative 4 is the integral from 0 to negative 4. It's an area problem. And big F of negative 2.5 is the area from 0 to negative 2.5. Big F of 0 is the area from 0 to 0. Big F of 4, the area from 0 to 4. Big F of 6, the area from 0 to 6. Whew, that's going to get exhausting. Now, some people have probably already thought one step ahead and said, oh, Herbert, this isn't going to be that bad. We did a bunch of those in Part A. That's true. We actually did do a bunch of them in Part A. So in theory, we could probably steal a bunch of our own answers and maybe we'll be in better shape. But another possible thing to think about is to really think, are all of these actually potentially going to be minimum and maximum points? Because maybe there are some where we don't have to waste our time. For example, I'm looking here at 0. The reason I'm looking at 0 is because I'm looking at this line chart. Remember how you can predict on a line chart where a min or a max is going to occur because you can think about the shape of the graph? I'm thinking about the shape of this graph according to what the line chart is saying. This graph must start out decreasing because its derivative is 0. So we know that the graph of big F starts out decreasing. Then it's going to go flat for a second. That's at negative 2.5. We know that because there's that 0 slope. And then it's going to start increasing because we can see that in the line chart. We can see the plus signs start to take over. Then it's going to go flat again at 0, but it's going to keep increasing. How far? I don't know, but it's going to keep increasing for a while until we get to the x-coordinate 4. Then it's going to go flat again at 4 and decrease again till we get to 6. So even though this is a pretty crappy little sketch, it is giving me a sense of things. Namely, that I can start to make a few predictions. I don't really know about these endpoints, so I'm definitely going to have to test those for sure. I'll put a little dot next to these. Negative 4 for sure and 6 for sure are like wild cards. I don't know what's going to happen there. But the only possible point that I can see a maximum for is 4. That's the only point that makes sense to me as a possible max. I'll put max question mark because I don't really know if it's a max for sure. I mean, maybe negative 4 is actually higher up and my graph was stupid or something. But nevertheless, I also can kind of deduce negative 2.5 must potentially be a minimum because it does look like the graph sort of bottomed out there. And 0 doesn't look like it could be anything. 0 is definitely not a possible low point because negative 2.5 is definitely lower than that. And 4 is definitely higher than it, so I can tell it's not a possible maximum point either. I'm going to use common sense and say to myself, hey, you know what? I'll bet 0 I don't even have to test because there's no way it's going to be a max or a min. Just based on what the line chart told me, there's no way 0 is going to be a crucial max or min point. So I'm going to get rid of 0 from my list of things to test. That's one fewer thing to worry about. You may argue it's trivial and that it might be easy to just get an answer for 0, but there's no chance it's ever going to be the max or a min. So sometimes prioritizing the ones that you know for sure are going to work can be helpful. So I know for a fact that negative 2.5 could potentially still be in the mix for a minimum. I know for sure that 4 could potentially be in the max for in the running for a maximum. So I have to test those. And now I'm at the point where I just have to test them all and see what I get. The biggest one will be a maximum. The smallest one will be the minimum. And I'll just have to see what I've got. So this is where, if you have the answers from Part A, you'll probably benefit from your own work. For example, big F of negative 4. If you did big F of negative 4, that was Part 8 in the previous question, Part A. So I'm going back to Part 8 here. It looks like the answer to that question was negative 2 if you did it. So I'm just going to poach my own answer here, negative 2. You could always redo the area if you really wanted to. Big F of negative 4 is plugging negative 4 into the big F function. That was the area of negative 4, but I'm saving myself the time just so I don't have to do that all over again. Big F of negative 2.5, unfortunately that I did not do on my previous answers, so I'm going to have to look at that really quickly. Big F of negative 2.5 would be this little region here. So it looks like I have a triangle, which is -1, height of 2, so that little height is negative, or that little area is -1. This is a rectangle with an area of 2, or -2, as it were, because I'm going left and up, negative base, positive height. And then this tricky little part looks like it has a height, or a base of -1/2. Do some scratch work here, times a height of 2 divided by 2. So -1/2 is the area there, or -0.5. So it looks like the area total from 0 to -2.5 would be these three values added together. That looks like -3.5. Now remember, these numbers don't mean a whole lot right now until I compare them to one another. So I'm just writing them for now, and then I'll go back and compare them in a moment. So big F of 4, I do have that. That was the answer from letter A, part 3. That's 2 pi, a nice big number. And big F of 6, I also had that from part A. Big F of 6 was 2 pi minus 2. Now because you're comparing things, it may be helpful to have 2 pi and 2 pi minus 2 as decimal equivalents, just so you have something that you can compare to. So should you need to, 2 pi as a decimal is 6.283, which clearly is a little bit bigger than these other two decimals. 2 pi minus 2 is 4.283, which is a little bit smaller than big F of 4. So now let's compare. Of these four answers, the smallest one looks like it is -3.5. The biggest one looks like it's 6.283. So I must be able to conclude then that I have found my minimum and my maximum. My absolute minimum is the smallest value I just found, and the absolute maximum is the biggest. So to phrase this answer, I would say that big F has an absolute min, and you can abbreviate these things, or you can write them all in full words. Whatever's up to you is fine. They don't care if you abbreviate on the AP test. Big F has an absolute min of -3.5. Now you might be looking at that going, no, Herbert, that's not right. Wait, aren't you supposed to put the x coordinate? The function value itself is the minimum value. So we actually say that the absolute min is -3.5. Some people parenthetically also include the x coordinate where it happened. It happened at the x coordinate -2.5, so you can write that if you want, but you don't have to. Always, we say that big F has an, and then we state whatever we need, in this case absolute max, and then we state the actual maximum value, that actual big value that we found. So 6.283, or for shortening purposes, 2 pi. And again, if you want to record where you found it, just for posterity, we found that at x equals 4, but it doesn't matter. The actual maximum is the y coordinate, or I shouldn't say y coordinate. The actual maximum is that area, the output value from the big F function. So min and max really kind of boils down to looking at your line chart, identifying possible critical points and end points that could potentially yield big or small numbers. Sometimes it helps to narrow down which ones could have been. So, for example, we did successfully predict that -2.5 really was where the min was, because we predicted that from the line chart. The graph was going down and then up, so we did successfully predict that -2.5 really was a logical place for a minimum to happen. And we also successfully predicted that at x coordinate 4, the maximum was also going to occur. So those predictions can be helpful, but they're not necessary. If you feel like that was too over your head, then the basic procedure that you can always follow is copy all critical points from your line chart. So -4, -2.5, 0, and 4. Copy any end points from your line chart, 6, and then plug all of those into the original big F function. Remember, max and min always plugs into the original function. So if it's the max and the min of the big F function, you have to plug them all into big F. If you already had those answers like we did, then it saves you the work, but otherwise you'd have to plug in each individual one and solve each individual one, looking for the biggest or the smallest answer that results. In the next question, we're going to look at concavity, which is another extension of our function analysis work, but unrelated to parts B and C. So make sure parts B and C make sense before you move on to part D. That way, if you have a question, you can sort those ideas out before we layer on something new.